In this video, we're going to review some of the key kinds of plots and the data types, as in the 4 levels of measurement, that are associated with some of these plots. We can't use all kinds of data with all kinds of plots. Certain plots work better or even require one or more of those data types, but not all. So let's go start with a not a box plot, a bar plot, perhaps the simplest and most common kind of plot. So in this case, we want to select the categories of interest, and we need some data to put in. Those data have to be a single value, so one data point or one value for each of the categories. And in Excel, we would go to Insert, the plot, and get that kind of box plot. So if we look at the features of this plot, we see the x-axis is a category. In fact, that is probably worth writing down, because this will change for some of the other variables. So x has to be a category, and the y variable is a value. So it could be a count, it could be a percent. In this case, it actually is a count, but it doesn't have to be. But y has to be a value of some sort. So we'll just say v for value. And by this, I mean it has to be either interval or ratio level. Maybe that's worth putting also. Interval or ratio level. And by category, this could be either nominal or ordinal. Those are our two levels that deal with categories. So that is what defines a bar plot. Categories on the x and a value on the y. And I think one of the problem set questions asked us to create a grouped bar plot. So here we can see the variables are related, or the categories are related. It's all about attending school, but there's 3 different categories. So in a group bar plot, we want these same 3 categories, but we also, and at the same time, want to visualize another variable, a second variable on this. For this particular example, we'll just take the top 2 regions. I'm not even sure what they're associated with, but that doesn't particularly matter. So we're going to keep our categories, but we're going to add another categorical variable, so another nominal or another ordinal level variable. And we do the same kind of thing, insert and a plot, and Excel will automatically, we'll put it over here, will automatically group things for us, and hopefully it groups it in the way we want it to. If not, we would just switch our data. So the attending school would be on the X's, and the regions would be, would be on our rows, and the regions would be in our different columns. In this case, it worked the way I wanted it to. So in a simple bar plot, we have effectively one region. We just have our categories, and our y-axis is a value. Here, our x-axis is still a category, our y-axis is still a value, but now we have a second variable and a second color being plotted. If we had a third region, then we could add a third color, and etc. If we add more than 3, I'd probably say 3 tends to be about the limit. Then those kind of plots get really confusing to make, and you should probably look at finding some other way to visualize your data. So again, to summarize what we have here so far, with a box plot, we have a single categorical variable and a value for each of those categories. This is called a grouped bar plot because we have a groups of 2 in this case. For a grouped bar plot, we still have categories, one categorical variable. We have a second categorical variable, which is the region, which differentiates the colors. And our y variable is, or the y value is still the number in each cell. So those are bar plots. We just kind of stop there. We can contrast that to histograms. So whereas a bar plot has categories on the bottom, like different categories, perhaps it works best looking at the data, whereas the bar plot needed 3 different columns, 3 different variables that way. A histogram is only based on one of those. So we could only look at the not attending school at a single time, or only look at attending school full time at once. And we end up doing that, and we do that because we are going to collapse all of the regions into a single data set. So for a bar plot, which we did here, we ignored all of these regions. We just took a single region and looked at those categories. For a histogram, we're looking at one category, and we're combining all of these together into a single data set. So I have this highlighted. Maybe we'll just stick with the data so Excel doesn't do anything weird for us. At least in my version of Excel, this is the histogram button. So let's move that down so we can visualize it a little bit better. I'm also going to change this just to give a few more bins. Let's do actually a bin width equal to 10. Let's see what that looks like. That's not too bad, so we'll go with it. So this is a histogram. Notice it also has bars, just like a bar plot. There are still numbers on the x-axis, or values. But instead of having categories like words, we have also numbers on the y-axis. So these are a range of values. These are the numbers 0, 1, 2, 3, 3.1, 3.2, all possible numbers between 0 and 10. And every time a value in the data, a row, had a value between the numbers 0 and 10, then the bar gets one notch higher. So we analyze the data, we interpret a histogram by looking at the height of the bar. And the height for a histogram is the number of times a data point fell within that region. So we had 7 data points that fell between 0 and 10. And that is 0 and 10 inclusive in this case. So we had 5 data points that were between greater than 10, which in our case is probably 11, to 20, and 4 data points between 20 and 30. No data points between 30 and 40. That is not necessarily the same way that we would interpret a bar graph. So the height here for a bar graph could be the number of times something happened. But for this particular data set, the height here is the count, so the number of students, or the number of people that were not attending school. So there were 55 students that did not attend school in that particular region. And the histogram, there were 7 rows, 7 regions that had a count between 0 and 10. So the bar plots and histograms, although they look the same, they do give us different information. A histogram is our empirical way of estimating a probability distribution. So when we have things kind of like the normal curve, which let's actually get the pen to work. We have something like a normal curve, which does that. If instead of having a smooth line, we were to draw little bars here, each of those bars would come not from a bar graph, but would come from a histogram. So we could imagine our histogram here, it would connect kind of like that. So it would not be a normal distribution. It would be this very far right skewed, I guess there's a mode, but it's certainly not a hump. The distribution would be kind of like that. So histograms are our best way of approximating a distribution in the same way that we've used normal distributions and t-distributions, that kind of thing. So height of the bars equals counts, and height of the bars for a bar plot is the value that's on the inside, generally not a count. So those are bar plots, grouped bar plots, and histograms. The third kind of plot that shows up a lot is a scatter plot. We don't necessarily have a data set that works well for a scatter plot. I don't know that we necessarily want to do that for these. But we can do, let's say we wanted to know if there was a relationship between the number of people who did not attend school and the number of people that attended school full time. When we're comparing 2 variables directly together, wondering how changes in one of them relate to changes in the other, we do that using a scatter plot and correlation analysis and regression analysis. So let's go make a scatter plot. We won't worry about the analysis part. We've had some other videos that do that. Right now we're just talking about making plots. So we're only going to deal with one series, so we don't have to worry about that. We have some x values, which will be the not attending school in this case. That equals bracket 1, just gets in the way, so we delete it out of the way. Let's compare that to attending school full-time. And there we go. So we can see, maybe we'll move this plot all the way out of the way, or not all the way out of the way. And we get a plot kind of like this. So we can see, in fact, maybe I'll just add the line because it makes it a little easier to describe. Great. So we can see there is a linear trend overall. And it's actually a pretty decent linear trend between the two variables that we plotted, the non-attending school and attending school full-time. And the key to knowing when to use a scatter plot is that each variable, the x and the y, needs to be a number, so interval or ratio level. And that applies for the x and for the y. And we use a scatter plot when we want to specifically evaluate the relationship between those data. So we're not categorizing anything. We're not doing a category versus count. This is the actual value on the x of one variable versus the actual value of the x on the other variable. We want to compare the two variables to each other directly.